Welcome back to Section 1.8 on Indirect Proofs, the 8th video in the Pearson Lecture Series. Let's start by defining an indirect proof. An indirect proof is a proof that uses indirect reasoning. Let's take a look at an example. Beth is having dinner with Sarah and one of Sarah's friends, Libby, Mercedes, or Kelly. Beth orders a chicken and spinach pizza to share for dinner. Given the clues above, which one is having dinner with Beth and Sarah? Well, Libby's a vegetarian, so she's not going to be able to eat the chicken. Mercedes is at the library, so she must not be at the restaurant. That means that Kelly must be the one that's having dinner with Beth and Sarah. Okay, now, when should you use an indirect proof? You're going to use an indirect proof when a direct proof won't work. So far, everything that we've worked on has been pretty direct. Let's take a look at an example of indirect proof. One method is proof by contradiction. So proof by contradiction has 3 steps. Starting with a statement, which is given as a conditional, which means P then Q. So step 1 would be to assume that P and not Q are true. Okay, so assume P and not Q are true. Step 2 is to show that not Q contradicts P. Show that not Q contradicts not P. Oops, sorry, just P. And then step 3, conclude that Q must be true. Conclude that Q must be true. All right, let's look at another method of indirect proof. Another method of indirect proof is proof by contrapositive. And it also has 3 steps. And if you prove the contrapositive, you have also proven the conditional. Okay, so contrapositive. Remember, contrapositive is not Q, then not P. Okay, so with proof by contrapositive, we are going to assume not Q is true. And then show that not Q leads to not P. Finally, conclude that P then Q must be true. And that's because not Q, then not P is true. Okay, let's look at an example because that's all pretty confusing. Let's say that we want to prove the contrapositive for if there is a snow day, then I won't go to school. So if we say the contrapositive would be if you go to school, we negate the conclusion, if you go to school, then it isn't a snow day. If you go to school, then it isn't a snow day. Okay, that is also true. So since the contrapositive is true, then the conditional is true. So we'll say it is true. Okay, consider this. What can we conclude from the following situation using indirect reasoning? So, given that Nadim spent more than $10 but less than $11 for a sandwich and drink, what did he get to drink? Okay, he spent more than 10 and less than 11. So let's first of all figure out what range the drink price is going to fall into. So we've got $11 minus the $8.49 that he spent for his sandwich, leaving him with $2.51. Or we've got $10 minus the $8.49 that he spent for his sandwich, leaving us with $1.51. So we know that he had to have spent less than $2.51 and more than $1.51. So let's take a look at the information that we have. Okay, he spent $8.49 on his sandwich. We know that. The cost for milk is $1.49. Okay, so the cost for milk, that's going to total less than 10. Okay, so that's going to be less than $10. So the milk is not what he got. Okay, the cost for orange juice is $2.49. That's going to fall into the right category. Let's look at the rest of them. The cost for a tropical smoothie is $2.89. Okay, now that one is going to be greater than, or total more than $11. So that one's going to be too expensive. And the cost for apple juice is $2.59. Okay, and that one is also going to be too expensive. So that means that Nadim had orange juice with his lunch. So this is the one that's going to fall in with the rest of our reasoning. Questions? Make a note of them and make sure that you ask me tomorrow in school. All right? Bye-bye.